Did smoke from Australia's infamous Black Summer trigger a 3-year-long La Niña? Between 2019 and 2020, Australia's bushfire season is considered to be the worst in the country's history, killing over 24 people, incinerating more than 40 million acres, and pushing critical ecosystems to the brink. But long after the flames were extinguished, scientists suggest the event triggered a ripple effect in global weather patterns.
Following on the fires for 3 years, we had the sustained La Niña event in the Pacific Ocean.
Let's break it down because it is a little complicated but fascinating. Recap: La Niña is a periodic climate pattern that has to do with cooler ocean temperatures in the tropical Pacific, which is an area that plays a huge role in global weather patterns. Normally, consistent winds push warm water from South America towards Asia, allowing colder water from below to rise up and replace it. This is called upwelling. Every now and again, those winds pick up strength, pushing more warm water toward Asia, resulting in more upwelling or cold water around South America. That's La Niña, the cool phase, and we just got done with a unique 3-year-long stint.
It's very unusual to get a 3-year La Niña, almost unheard of without a preceding El Nino event. So that suggests something really was unique about this event in nature. And so the first question was, where did it come from?
Scientists aren't exactly sure what triggers a La Niña to form or its opposite, an El Nino. But they have identified major events that can tip the scales in favor of one or the other to form.
Most of our studies on this have looked at volcanic eruptions, and it's never really been shown before for wildfire.
Major volcanic eruptions that spew a bunch of smoke, ash, and rock into the atmosphere can briefly lower global temperatures. Now, compared to a volcano, wildfires are much smaller in scale, so we really don't see huge effects like that. But as we mentioned before, the 2019-2020 bushfire season was anything but average. So the bushfires began in July of 2019 and lasted through January of 2020. The size and unprecedented intensity of these back-to-back megafires were unlike anything seen in recent history.
Really, the unusual part of this fire season was later in the season, so really the November through January timeframe, and that's when the fires really became large in the eastern and the southeastern part of the country.
According to NOAA, the massive infernos injected close to 1 million tons of smoke into the atmosphere.
And in fact, we had all these pyrocumulus clouds, so these large, deep clouds that resulted from the heat of the wildfire. It looks like a volcanic eruption, really. It's just this plume of smoke into the atmosphere.
Typically, smoke only lasts in the air for a couple of weeks, but the ongoing fires were continually putting it back in the atmosphere, where wind patterns occurred in such a way that they carried this near constant stream of smoke to the tropical Pacific.
And so when you add these large quantities of smoke to the southern hemisphere atmosphere, you get a big change. The southern hemisphere is somewhat different than the northern hemisphere in that there aren't a lot of factories, there aren't a lot of cars, there aren't a lot of people. As a result, the atmosphere is very clean, doesn't have a lot of pollution. So you go from almost a pristine, pure environment to one that's really filled with smoke and particulates.
This change caused clouds over the eastern Pacific Ocean to become brighter, thicker, and longer lasting. The brighter the clouds, the more sunlight is reflected back into space, to the extent that it cooled sea surface temperatures.
And that kicked in a whole bunch of feedbacks that are common during La Niña. Once that kick was given to the system by the wildfires, the system was predisposed to stay in a La Niña state.
But this leaves us with one question. Could this happen more often as fire seasons intensify with climate change?
How this acts as a feedback under climate change, we really don't know. And so this is really something, a major kind of blind spot that we are going to take a good hard look at over the coming years.